Alright, this is the day 10 homework lesson, and we are continuing to talk about vertex edge graphs. Now, in this particular situation, you are mixing different solutions in a chemistry lab. Some solutions can be mixed together while others cannot. The vertex edge graph at the right represents 5 types of solutions. An edge connecting two vertices indicates that those two solutions can be mixed together. Alright, so this is true or false. All the solutions can be mixed together. That is definitely going to be false. For example, there's no direct link between the G and the J. So that means G and J cannot be mixed together, nor can F and J or G and K. Those cannot be mixed together. Solution F can be mixed with any other solution. Well, F can be mixed with G and H and K, but not J. There's no connection to J. So, false. Solution H can be mixed with any other solution. That is true. There's a link between H and G, F, K, and J. That means H can be mixed with anything. Okay, so that is true. Solution K can be mixed with exactly 3 other solutions, J, H, and F. So that's true. Now, in exercises 5 and 6, use the vertex edge graph that shows a portion of the city or town where you live. The distances are given in miles. Okay, you're going from home to your cousin's house. Okay, so we're going from home to the cousin's house. What is the shortest route and distance? Okay, it seems to me that the shortest route is going to be like this. Alright, to the cousin's house. So it looks like from here to here to here, alright, those 3 lengths. So that would be 2, 4, 7 miles. Now we can look at other things, like say if I went around this way, that would be 4, 8. So that's longer. Okay, other than coming this direction, the only other thing would be to come all the way around like here. But whereas if I go this way, that was 4. But if I go this way, that's 6. So this is the shortest distance and the shortest route. Okay, so the shortest route is from home to the pizza shop. Okay, it's the home to the pizza shop to the cousin's house, and that's going to give us 7 miles. Alright, so that's 7 miles. And then for number 6, you're at home. You need to go to your friend's house and stop at school. What is the shortest distance, including your return home? Okay, so let's start over again. It says you're at home. Okay, now we need to stop by your friend's house. Sorry, we need to stop by your friend's house and school. But then we need to get back home again. So what is the quickest way, what is the shortest distance to do that? To me, it seems like it's going to be this type of deal. Alright, say if we went to the friend's house. Okay, so the shortest distance to the friend's house would be like this. Bam, bam, friend's house. Okay, that's a distance of 4 so far. But then I have to get to school. If I go this way to school, that's going to be 6. If I go that way, that's going to be 7. So from here, the best thing to do would be to go like this. Okay. Now, I still got to get home. Now, if I went back the way I came, that would be 3, 6, 10. Okay, it's taken me 10 units to get here. So if I retrace my path, that would be 10. On the other hand, if I continued my journey, all right, so far I've been going in this direction. Okay, if I continued on this way, okay, that's 4, 7, 8. So this path only takes 8. So rather than going back the way I came, it would be quicker just to continue in a loop, and it will only take me 8 instead of 10. Okay, so 10 plus additional 8, that is 18 units. So the shortest distance, including the return home, should be 18 miles. Okay, and that's the route that we would do it. Okay, number 7 through 9. Write matrix M that represents the vertex edge graph. Okay, now remember, to make a matrix with these things, we have got to 1, 2, 3, 4, 5. So this is going to be a 5 by 5 matrix, so it's going to take a little bit of space. Alright, we're just going to have to deal with it. Maybe I'm going to zoom in. Okay, so we have, like for instance, R, S, T, I'll just go ahead and put V, U. Alright, so I'm going to put the same thing down here. R, S, T, V, U. Okay, that's a V. Okay. So, we're supposed to make a matrix for number 7, right? A matrix M that represents the vertex edge graph. So here we go. None of these are connected to themselves. So R to R, S to S, T to T, V to V, U to U, those are all nothing. But between R and S, there's a double connection. So I'll put a 2. All right, same thing, S to R, duplicate. Between R and T, there are no connections from R to T. So same thing, T to R. But what about RV? R to V, there's just a single connection. And then what about R to U? R to U, there's nothing. Okay, what about S? S to T. S to T, there's nothing. So same thing, T to S. What about S to V? Okay, S to V, there's a double connection here. All right, there are 2 pathways from S to V. So I'll put a 2 here and here. Okay, what about S to U? There's a single pathway between S and U. Same thing, US. All right, moving on to the T's. T has a double connection with U. All right, well, I guess I should have done V first. So T to V, nothing. Same VT. Now T to U, like we said, there's a double connection from T to U. So that'll be the same thing from U to T. And then that leaves V, U. All right, V to U, there's just a single connection. So same thing, U to V. Okay, so this is our matrix representing the vertex edge graph. Okay, now using a graphing calculator, calculate M squared. Now I want to show you how to do it using the calculator. In case you don't have a graphing calculator at home, here's what you could do. Alright, if you go on Edmodo, you'll notice that here is one of our recent posts. Thanks Dayun Kim for sharing this with us. there's a matrix calculator. So if we just use this link, all right, and that's going to bring us to this matrix calculator app. Now we're supposed to be squaring this matrix, which means multiplying it by itself. So this is a 5 by 5 matrix. So let's use the app to make 2 5 by 5 matrices, and if we just make them the same, then we're multiplying by itself. So we'll just do the same matrix twice. Okay, let me see if I can get this over there. Okay, so here we go. All right, so the matrix is 0 2 0 1 0. Okay, and then I might as well do it here. So that's 0 2 0 1 0. Okay, and then the next row is 2 0 0 2 1. So that's 2 0 0 2 1. 2 0 0 2 1. Now the last one is 4 zeros and a 2. All right. The next one is 1 2 0 0 1. Okay, so that's 1 2 0 0 1, and then 0 1 2 1 0. 0 1 2 1 0. Okay, so this says A and B, but it's really the same matrix twice. So if we multiply these together, then it's really going to be this matrix squared. Okay, so this button seems to suggest I can do AB, which would be A times B. So boom. So they're telling us that the result is going to be this matrix, okay, which this should be a 5 by 5. Yep. So this is our solution matrix right here. All we have to do is recopy it. Okay, and I'm just copying down the squared matrix that we just found. So this would be, look what you made me do. Wrote down the wrong number. Okay, 43262, and then 32026. Okay, I just copied all these numbers down. All right, fine, that's done. Okay, so what we have here is the same matrix squared. Now this is critical. I'm going to hold you responsible for this. You need to know what the meaning of each number is when you square the matrix that came from a vertex edge graph. So remember, when you look at a vertex edge graph in matrix form, each one of these numbers tells you how many ways there are to get from one point to another if you're just going to use one path. Okay, so if I want to get from R to S, I could, if I'm just using one path, then boom, I could go that way, that would be 1, or I could go this way, and that would be another. Okay, so those are your two options, that's why there's 2. Now, if you square the matrix, now each one of these numbers represents how many ways there are to get from one point to another using 2 paths. Okay, so this exponent tells you how many paths you have to use. Okay, so for example, if I want to get from R to S using 2 paths, Here's one way I could do it. I want to go from R to S. So I could, for example, I could go from R to V to S. Okay? That's one way I could go from R to S using two paths. So that's one way. Or I could go from R to V, and then I could go this way. Okay? So that's another way I could go from R to S using two paths. Okay? Now, according to this chart, if I want my two-path chart, because I squared it, if I want to go from R to S using two paths, there's only two ways to do it. So the two ways I just showed you, all right, R to V to S this way, or R to V to S this way. Those are the two ways. Okay? If I cubed it, it would mean the number of ways I could get from R to S using three paths. If I did fourth power, it'd be how many times I could get from R to S using four paths. Okay, so this number tells you how many paths you have to use. Okay, so with that in mind, now we're going to use the matrix that we just calculated, all right, the one we were just playing with, the two-path matrix, to answer these questions. So, find the number of ways you can travel between the two given towns using two roads. Okay, that's two paths on this vertex edge graph. Okay, and this is a two-path matrix because we squared it. So, between town R and town V, so R and V, I see the 4 from R and over at V, that's a 4. That means there are 4 ways to go from town R to town V using two roads because we squared it. All right, what about T to S? Okay, from T to S, that would be right here, T and S. There are 2 ways to do that. Okay, how many ways can I go from town V to town S using two roads? V to S. Okay, V to S, that's 3. There's 3 ways I could go from V to S using two roads. How about S and back to town S? Okay, notice when we did S to S and T to T, it was all zeros before, because there's no way to get from a town back to itself using only one road. At least you have to go one path, and then you had to come back. Okay, so there are no ways. But now, if I look S to S, there are 9 ways to get from S back to S. Let's look at a couple of them. If I want to go from S to S, here's one way. I go from S to R and then back to S. Okay, that was 2 paths. SR and then R to S. So that was one way. Here's another way. I go from S to R and back to S. That's another way. Or I could go from S to V and back. Or I could go from S to V this way and back. Okay, what else? Or I could go from S to U and back. Okay, so that's what, I took one of them off again. We went from S to R and back. So there I've showed you 1, 2, 3, 4, 5 of the ways. What else? From S back to S. Oh, okay. I could do these as loops. Okay, so here's another way. I could go from S to R this way, and then back to S like that. So that would be another way. Okay, or I could go from S to V this way, and then back like that. Okay, so those are some of the ways to go from S and then back to S using two paths. So there should be a total of 9 of them if you counted them carefully. But we can just get it off the graph, there are 9. Alright, just wanted you to get a feel for what that's really saying. Okay, again, if I wanted to know how many ways of getting from one place to another using 3 roads, then I would cube it. 4 roads, 4th power, and so on. Alright, that's enough of that. Let's wrap this up. Alright, now we're just supposed to draw some vertex edge graphs. Easy enough, right? Okay, we have Colorado, Nebraska, Iowa, Kansas, and Missouri. Okay, and let's talk about who. Let's put some dots here. So dot, 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 and dot. All right, now let's show the shared border. So Colorado. All right, Colorado shares a border with Nebraska. All right, does it share a border with Iowa? No. Does it share a border with Missouri? No. Just Nebraska and Kansas. So that's it. All right, let's move on to Nebraska. Nebraska shares a border with Colorado. Already got that. Shares a border with Iowa. Shares a border with Missouri. And it shares a border with Kansas. So Nebraska shares a border with everybody. All right, what about Kansas? Kansas shares a border with boom, boom. All right, Kansas shares a border with everybody except Iowa. So I've already got those two. So here's my Kansas-Missouri border. All right, but not Iowa. All right, what about Iowa? Iowa shares a border with Missouri and Nebraska. That's it. So I've got Nebraska. Here's my Missouri. All right, let's just double check Missouri. Missouri shares a border with Iowa, Nebraska, and Kansas. There's Iowa, Nebraska, and Kansas. So boom, there's my vertex edge graph. All right, let's do it again for number 11 and 12. Okay, so we have Indiana, Ohio, Pennsylvania, Kentucky, West Virginia, and Maryland. All right, let's see what we got. All right, Indiana shares a border with Ohio and Kentucky, and that's it. Okay, Ohio shares a border with Indiana and Kentucky. Okay, and West Virginia. And Pennsylvania. Okay, but not Maryland. Okay. Pennsylvania. Pennsylvania shares a border with Ohio. All right, and West Virginia. And Maryland. Okay. Now Maryland shares a border with Pennsylvania and West Virginia. All right, but doesn't quite get to anybody else. All right, West Virginia. Obviously, it shares a border with Maryland and Pennsylvania and Ohio, but also shares a border with Kentucky. And Kentucky. Kentucky shares a border with Indiana, Ohio, and West Virginia. Boom, boom, boom. So that would be a nice little vertex edge graph for number 11. All right, last one. Okay, let's do Tennessee, North Carolina, and let's do Mississippi, Alabama, Georgia, and South Carolina. Okay, in fact, let me move these in a little bit. Just in case, just in case. Okay, here we go. All right, let's see what we've got here. Tennessee. Tennessee shares a border with everybody except for South Carolina. All right, so Tennessee shares a border with everybody except South Carolina. Boom. Now North Carolina shares a border with Tennessee, Georgia, and South Carolina. So there's Tennessee, Georgia, and South Carolina. All right, South Carolina shares a border with North Carolina and Georgia. So there's North Carolina and Georgia. Georgia, our home state, shares a border with everybody except for Mississippi. Okay, so border, everybody except for Mississippi. Alabama shares a border with Mississippi, Tennessee, and Georgia. So there's Mississippi, Tennessee, and Georgia. All right, and Mississippi. Mississippi just shares a border with Tennessee and Alabama. There's Tennessee and Alabama. So that would be your vertex edge graph for number 12. All right, I hope this was helpful, and I will see you on the next video.